All right, this is 7.7a, Elementary Algebra Applications. Decided to use a green board today. No reason, just, I don't know, the black just kind of gets to me after a while, I guess. All right, so number problems, example 1. And these are just story problems that we're just going to look at them, and you just hopefully get the hang of them as we go along. So we've got two numbers, okay? One number is twice another. Okay, which one do we know the least about, the one number or the other number? Well, we know one number is x, and the other one is twice x, okay? The sum of their reciprocals is 9/2. So what is the reciprocal of x over 1? It's 1 over x. What's the reciprocal of 2x over 1? 1 over 2x. So what does it say about the reciprocals? If we add their reciprocals, we get 9/2. Okay? So we like to get rid of the fractions. Remember a couple lessons ago we found the LCD and multiplied the whole thing by the LCD, and it got rid of the fractions. Well, what is the LCD of x, 2x, and 2? Well, it's going to be 2x, right? That's what's common to all of these, is an x here and a 2 here, so 2x would work, and that's a 2x. So let's multiply the whole thing by 2x. So 2x times 1 over x plus 2x times 1 over 2x equals 2x times 9/2. Cancel that and that. Cancel that and that. And again, you have to have your fractions disappear. That was the whole point. So we get 2 plus 1 equals 9x. Okay? So 3 equals 9x, divide by 9, divide by 9, those go away. X equals 3/9 or 1/3. Okay? So it says find the two numbers. So one of the numbers is 1/3. Which one? The x. We found x to be 1/3. Now we take 1/3 times 2, and we get our second number. So there's our two numbers there. So the next section is on motion problems, and if you remember for these we had a formula, and I'll write it all out here. Which is distance equals RT. Now let's say that we aren't looking for, this is if you're wanting to find the distance. You multiply the speed times the time. Let's see, we want to find the rate. How fast are you going? Well, the rate is going to be distance divided by time. And if we're looking for time, that's going to be the distance divided by rate. So these three formulas are ones we're going to use for these sections on motion problems. So what do we have? We have example 2, the old boat in the river problems. Okay, so a boat travels 30 miles up a river in the same amount of time it takes to travel 50 miles down the same river, because one he's going upstream and one he's going downstream, so he's able to go faster downstream. If the current is 5 miles per hour, what is the speed of the boat in still water? So we're going to know how fast the boat is going when there's no current at all. All right, so got us a little chart. Okay, so the distance, the rate, and the time. Okay, so we've got upstream and downstream. Okay, so what is the distance upstream? 30 miles. What is the distance downstream? 50 miles. How fast is this boat going? Well, the river is going 5 miles an hour. So when it's going downstream, he's going 5 miles. He's going whatever speed the boat is plus 5 miles an hour, right? when he's going downstream. So if his boat's going 20 mile an hour downstream, or if his boat can go 20 mile an hour and he's going 5 mile an hour, in the stream is 5 mile an hour, and he's going downstream, he's going 25, because that 5 mile an hour that the stream is going is pushing the boat. Now when he goes upstream, he can go his speed, but the river is pushing him backwards, so it's pushing him back at 5 mile an hour. So even though his boat would be going 20 mile an hour in flat river, going against the current's pushing him and slowing him down 5 mile an hour. So whatever his speed is, minus 5 mile an hour is how fast he's actually going there. And time. Do we know anything about time? We really don't, except we're going to use, let me get a different color here. We're using this formula right there. T equals distance over rate. So that's how we find time. So we're going to take our distance and put it over rate, and that will be his time. And then distance over rate. Okay. Now we filled in our table. Let's see what we're trying to do. What is the speed of the boat? Okay, so notice that these here, it says a boat travels 30 miles up a river in the same amount of time. So there's the key, in the same amount of time. So the time going upstream is the same as the time going downstream. Well, what is the time going upstream? It's right there, right? Time going upstream is this, and it equals the time going downstream. That's what the story problem says. So 30 over x minus 5 equals 50 over x plus 5. Now I've got a proportion, and I can solve it by multiplying 30 times x plus 5 equals 50 times x minus 5. So that gives me 30x plus 150 equals 50x minus 250, and 50x. And we just move things around. So let's subtract 30x here. I always try to subtract the smaller number, just so when I subtract these I get a positive number. Okay, so I'm going to add 250 and add 250. Okay, all right, let's move some of this up here and out of the way. So 400 equals 20x. Divide by 20. Okay, so I end up getting x equals 20. Okay, x equals 20. So what does that mean? That means the speed of the boat in still water is 20 miles an hour. So let's look at example 3, which is very similar. Tina is training for a biathlon. To train for the bicycle portion, she rides her bike 15 miles up a hill, then 15 miles back down the same hill. All right, so she's riding 15 miles up a hill, 15 miles down the hill. So their distances are the same, 15 miles each way. So let's make ourselves a little chart here. Distance, rate, time. And we've got going uphill, and we've got her going downhill. Well, let's see what we've got. She rides her bike 15 miles up a hill. So her miles is 15 miles up a hill, and then 15 miles back down. So her distances are 15 miles. Let's see. The complete trip takes her 2 hours. Okay, so the complete trip takes her 2 hours. If her downhill speed is 20 miles per hour faster than her uphill speed. So her downhill speed is 20 mile an hour faster. So whatever her uphill speed is, we're going to add 20 to it. Well, do we know anything about her uphill speed? Absolutely not. So her uphill speed is x. Her downhill speed is faster, 20 mile an hour faster. So x plus 20. And then we've got time. Time equals distance over rate, right? We did that in the last one. So, distance over rate, 15 minus x. And downhill, our rate would be 15 over x plus 20. All right, so what are we going to do with that? Her time uphill plus her time downhill, it says, is 2 hours. So 15 over x, that's her time uphill, plus 15 over x plus 20, her time downhill, equals 2, right? Okay, so that's how we put our equation together. Okay, so time 1, or time up, plus time 2 gives us our total time. All right, so what are we looking for? We're looking for the rate. That's what it says. How fast does she ride uphill? So this is the number that I'm looking for, x. And what I did here is I took the information in this table and I made an equation. You cannot solve this unless you take the information in the table and make an equation out of it. And they will give you the information necessary in order to make an equation. All right, so least common denominator, x and x plus 20. So I'm going to multiply, so x times x plus 20 is my least common denominator. And each one is going to be multiplied by x times x plus 20. And your fractions will disappear. Alright, so that x will go away. Those will cancel. And we didn't have any fraction there, so we're good there. So 15 times x plus 20 takes care of that. Plus 15x takes care of that. Equals 2x times x plus 20. Let's go ahead and distribute everything. Okay. So let's move all this up. Alright, so we're going to rewrite all of this. 30x plus 300 equals 2x squared plus 40x. Okay, we'll subtract 30x there and 30x there. So that gives me 300 equals 2x squared plus 10x. Subtract 300 from both sides. And we get 2x squared plus 10x minus 300 equals 0. Remember, you have to set it equal to 0 when you have an exponent of 2 there. So we'll factor a 2 out, and then we'll finish this on the next video. So we'll copy this and move it over. Alright, so we'll start on 7.7b where we left off here.